we have two numbers, x and y, so that you can add them up and they make 16. And then they tell us to maximize and minimize this quantity. There's two variables here. You can ever make your life simpler and have just one variable, then go ahead and do it. Like if I was to solve this for y, then I could have something I could plug in. So this is the same thing as x times 16 minus x. This is the quantity we're trying to maximize and minimize. Let's call that a function of x. And so if you want to maximize something, here I haven't done any calculus yet. If you want to maximize or minimize a function, the maximums and minimums happen either at the endpoints of the function or where the derivative equals 0, right? Because if the derivative equals 0, you've got a horizontal asymptote. You've reached a peak or the bottom of a valley. So if you take a derivative, you set it equal to 0. If you solve this, you get x equals 8. So that's the only potential critical point. That's the only potential max and min, I should say, at x equals 8, or at the endpoints. It says that the numbers are non-negative, x and y. That means x is between 0 and infinity. I actually don't know what the right notation there is. Here, you can say it like this. X is an element of the set of numbers 0 to infinity. Same thing for y, because it's non-negative. Okay, so you want to test endpoints. So 0 for x, 0 for y. And then we have x equals 8 as a critical point, which means y equals 8 would be the corresponding y value. If you plug this in, 8 times 8 makes 64, right? Or if you plug it in here, same thing. So in other words, if you plug in 8 into the function, you get out 64. So let's test the value to the left and to the right. So if you plug in 7, then you're going to have 7 times 9. Oops. So it makes 63. And if you plug in 9, you get 9 times 7. So it's also going to be 63. So this is a maximum. So the quantity is maximized when x equals 8 and when y equals 8. So that's a maximum. With calculus, we know that maximums and minimums have only two different types of places they can occur. They can occur when the derivative equals 0, which we just found, or they can occur at extreme endpoints. Okay. So x is a positive number, y is a positive number, but they're restricted, right? Because x plus y has to equal 16. If you actually think about it, if I actually think about it, this should actually be restricted up to 16 because they have to add up to be 16 and not be negative numbers. So between 0 and 16 is the possible x values, and 0 and 16 are the possible y values. So since we wrote it as a function of x, we don't even have to worry about the y values. We just need to plug in x equals 0 and x equals 16, and then we've tested all the possible places where we have maxes or mins. Right, so just another quick recap. Maxes or mins can only happen when the first derivative equals 0 or at the endpoints. So if we plug in x equals 0, the function gives us 0 if you plug that in. And if you plug in the other endpoint, if you plug in 16, then you're going to get 0. So those are both going to be minimums, because if you test a point to the right, like f equals 1, that's going to be something bigger. That's going to be 15. Right, so this is a minimum, and this is a minimum because 0 is as low as you can go for this range of values. Okay, so when x is 16 and y is 0, we have a minimum. And when x is 0 and y is 16, we also have a minimum. And up here, the pair was x. We found x is 8 and y is 8. That's the maximum.